Okay, this is video 10-2. We're going to be working through Explain 1, which is using slopes to classify figures by right angles. And of course we're going to be looking into whether we have rectangles in example 1 here. So example 1 says, show that the figure is the given type of quadrilateral. It says, show it's a rectangle, which hopefully makes sense why we're talking about right angles. For step 1, we're of course going to list the coordinates just that we see on our diagram over here. Always a good idea to make sure you list the coordinates first. And then we're going to start calculating slopes just like we did in the previous video 10-1. This time, however, we're not going to be looking for the slopes to be the same, but for consecutive sides to have slopes that are opposite reciprocals, remember. Now, the way that the book states this is that the slope of one times the slope of the other is going to give you a product of -1. And if you think about that really quickly, just off to the side here, if we had a fraction slope of a over b, and then we multiplied it by the opposite reciprocal of a over b, which would be opposite, so change the sign, and reciprocal, flip it around, b over a. If we multiplied those two fractions straight across, numerator times numerator, denominator times denominator, we're going to get a negative ab over AB, which hopefully you know would cancel right out to just -1. So that's why they're looking at the product of the two consecutive sides slopes to be -1 each time. If it's a rectangle, there need to be 4 pairs of consecutive sides that have opposite reciprocal slopes or a product of -1. So just like before, we're going to identify what the slopes are. So we calculate the 4 different slopes of the sides. And you can see there that slope AB here, we did 2 minus -1 and 3 minus -3, and we got positive 3 over 6, or 1/2 when we reduce. BC, we're going to do 0 minus 2 over 4 minus 3, and we get -2 when we simplify that. If we look at CD, that slope is going to be -3 minus 0, and -2 minus 4, and then again reducing -6 over -4, we get to a 1/2, and so we have DA left, and we're going to do a -1 minus -3 and a -3 minus -2, which also is going to come out to a -2. So we can definitely see that it is a parallelogram, which is good because only rectangles, if it's a rectangle, it's already a parallelogram. So there's our two opposite sides that have the same slope, just like before in the first video. But now we're going to be comparing, are the slopes consecutive sides, are they going to be having a product of -1? So AB times BC, the slopes are 1/2 times -2, and yes, that product is -1. Then BC times CD, does that product equal -1? Yes, it does. Slope of CD times DA and DA times AB in the same way. You can see that. You want to make sure you write all those different 4 comparisons out though. And then finally, we can conclude here that since quadrilateral ABCD is a rectangle because it's a quadrilateral with now 4 right angles. In part B, we're supposed to confirm that JKLM is a trapezoid with 2 right angles. Instead of confirming 4, we need to confirm 2. So here we are in part B here. Again, we're going to write down the coordinates. So the first thing we want to do is fill in L. L is the point 2, -2, and M is the point -1, -1. And then we need to find the rest of these slopes. They found JK for us, so we'll go to KL next. It's going to be -2 minus -1. Oops. -2 minus -1 over 2 minus 3 is -3 over -1, or +3. The slope of LM, just filling in some coordinates there, now -1 minus -2. And then over -1 minus +2 is going to be +1 over -3, and we get -1/3 And then finally the slope of MJ, filling in what needs to be filled in there. It's going to be 3 minus something. It's going to be -1. And then -3 minus -1. So we have 4 over -2. And that's equaling -2. So hopefully it makes sense that number one, it's a trapezoid. Let's continue this on to your next page here for our comparisons that need to be filled in. Now we're going to compare the slopes. Since the slope of JK is the same as the slope of LM, those opposite sides, then we know that JK is parallel to LM. So that automatically makes it a trapezoid. But we were asked to make sure it's a trapezoid with 2 right angles, remember. So since we can say that the slope of JK times the slope of KL, which was 1/3 times 3, that product is -1, then we know we have a right angle there. And also the slope of KL times the slope of LM is the reverse here. It's +3 times -1/3. Then that's going to be also a product of -1. So JK is perpendicular to KL, making a right angle, and KL is also perpendicular to LM, making another right angle. So quadrilateral JKLM is a trapezoid with 2 right angles, because JK was parallel to LM. That makes it a trapezoid. And then the measure of one of the angles, which angle do we know it has to be? Well, if JK is going to be consecutive with KL, then that means this first angle is angle K, which has a 90-degree angle. And also the measure of the second angle, and again compare it to KL is bumping up against LM, so you can see the repeated letter there. The measure also of angle L is 90 degrees. And that takes us through this next exercise chunk here. So you just have one your turn problem this time. And go ahead and look down here at DEFG. Again, make sure you start by writing down the letters and the coordinates for each point. So I'll just start you off here, DEFG, and just fill in those coordinates so that you have numbers to look at rather than trying to look at the diagram and figure out those different coordinates each time. Okay? That takes us to the end of this video. We'll see you tomorrow.